Hi guys, well done those of you who've been doing the gas calculations challenge at home. I know it's tricky, it is hard, it is a challenge. I'm just going to explain how to do question 2. One method used to inflate airbags in cars is to use nitrogen produced chemically from the decomposition of sodium azide. The sodium formed reacts with potassium nitrate to give more nitrogen. So this is sodium azide, NaN3, potassium nitrate, KNO3. Question A says, in what ratio by mass, that's important, must the sodium azide and potassium nitrate be mixed in order that no metallic sodium remains after the reaction? So essentially, this first reaction happens, makes sodium. That sodium is used up in that second reaction and we don't want any left over. So we need to know how much by mass they want potassium nitrate needs to be added to this sodium azide for it to react. To do this, you've got to look at the equations. So I'm just going to write the equations down. First one, we've got 2 moles of sodium azide decomposing to form 2 moles of sodium and 3 moles of nitrogen. And then the sodium then goes on to react with the potassium nitrate. And in that reaction, you need 10 moles of sodium to react with 2 moles of potassium nitrate to make potassium oxide, sodium oxide. The rest of this isn't that important, but I'll write it out, and nitrogen. But it's this bit that's important at the start. So the question is asking what ratio by mass must the sodium azide and the potassium nitrate be mixed. So if you look here, if you've got 2 moles of sodium azide, you produce 10 moles of sodium. You need, no you don't, ignore me, 2 moles of sodium azide produces 2 moles, but you need 10 moles of sodium to react with 2 moles of potassium nitrate. So I'm just going to scale this up to think if I needed to get 10 moles of sodium. So if I put 10 up here, because I know that those 10 are needed here, in order to get 10 moles of sodium, I would need 10 moles of sodium azide. Okay, because it's a 2-to-2 ratio there, it's going to be a 10-to-10 ratio. Now what that tells me is, in order to get 10 moles of sodium, you need 10 moles of sodium azide. In order for this to fully react then, your ratio would be 10 moles of sodium azide to 2 moles of potassium nitrate. All right, so if that's a bit confusing, just look again. In order to get 2 moles of potassium nitrate to react, you need 10 moles of sodium. In order to get 10 moles of sodium, you need to decompose 10 moles of sodium nitrate. Now that isn't the end of the question, because you're asked the mass. You've got it in the moles. Now then, that's dead simple. Then you are just then changing, using whatever you do. Number of moles is mass divided by MR. Went a bit smaller. Oops. So we've got the mass here. We've got 10 moles times by the MR of sodium azide, which is 65. If you're not sure how to work that out, well, you should just know how to work out an MR by now. 2 moles of potassium nitrate, and the potassium nitrate is 101.2. This is our ratio, mass ratio. We have then 65 grams to 202.2 grams, or to simplify that ratio, divide by the smaller number, which is this, 1 to 3.11, 1 gram to 3.11 gram. So what that shows is you need 1 gram of sodium azide to 3.11 grams of potassium nitrate.